In earlier scenarios, we had been determining in what order to unload and load the cargo jets. In this particular scenario, the cargo manager is wondering if we should come up with yet one more sequence for unloading and loading the cargo jets. Okay, now, last time we used Johnson's rule. This time, we're going to consider the critical ratio rule. Let's take a look. The cargo manager at Global Freightways Edinburgh Satellite Center feels that a good sequence for all 5 jets cannot be developed without considering both the processing requirements and the planned departure times of the jets, and wonders if the critical ratio would be a better priority rule for this situation. Oh, wait, before we go any further, critical ratio. What do we mean that he thought you needed to consider both the processing requirements and the planned departure time? Critical ratio is any ratio essentially of time remaining to work remaining. I'm just jotting that down to myself there. Oh, right. So last time we used Johnson's rule and we were only looking at processing times. If we were to use the critical ratio rule in order to sequence these jets, we'd have to look simultaneously at time remaining would be the processing time, and time remaining would be the departure time until departure, and the work remaining would be the processing time. Oh, all right. So if the Edinburgh Center uses critical ratio to select the courier jets for processing, what sequence would result? You see we have the same blank space. This is essentially all that we're trying to decide is in what order to process each of these flights. Okay, so sounds like it shouldn't be too difficult. We'll just calculate this ratio for each one of the flights, and with critical ratio, you're always interested in who has the smallest ratio. Well, it starts out being that simple. Okay, because think about it this way. At the beginning, we haven't done anything. We're only picking the first flight. Okay, we're only picking the first flight based on the data. Now, if you have the note frame, it has the original data concerning processing time and the scheduled departure, which is essentially the time remaining. So I could use actually this existing table that was pasted in here. I could use it as a table to calculate my first set of rules, because I just need to know what is the ratio. So I'm just drawing some lines here so I keep this straight. What is the ratio of the right-hand column to the left-hand column in each case? For instance, in the case of Belfast, the time remaining until departure, if we were trying to pick right now, okay, well, that's 1 hour. Okay, so the numerator is 1. The work remaining, so to speak, nothing's been done on that flight. There's a half an hour worth of work. So it's 1 divided by 0.5. We would say, well, the critical ratio value is 2. Well, for Belfast anyway. Now, I need this value for each one of them, so I do that for the others. 2.6 is the departure time for Birmingham, right? Divided by, it's only 15 minutes, a quarter hour worth of work. Okay, so that ratio comes out a lot bigger. I get like 10.4. So, all right, well, that's Birmingham right there. Dublin, let's see, time remaining is 2 hours from now. Work remaining, that was 0.65 hours worth of work. So I get like 3.1 is the result. All right, well, I record that. Manchester, 1.5 hours remaining till it has to leave. 0.75 hours worth of work is another critical ratio value of 2. All right. And then in the case of London at the very bottom, 3 hours until it has to leave, but it's 1.5 hours worth of work. So that is also a critical ratio value of 2. Oh, all right, so we calculated these ratios. How's this supposed to help us decide which jet we should start working on? You always look for the smallest number. The assumption is that the most critical job, as far as let's get busy on that one, is going to be the one with the smallest number. Now, wait a minute. This particular list, we have like a three-way tie for smallest number, right? Belfast, Manchester, London. It's true. What's that mean? You get to pick any one of them, basically, unless you were told there was like some sort of, tie-breaking rule. I'm a big fan of alphabetical, just, among the ones that have tied. So I suggest, okay, then fine. We'll pick Belfast, just to break the tie. It has one of the three smallest critical ratios, and great. Belfast goes first. You think, great, all right, right? And then we put the other two in that have a 2, right, is second and third, and then the other one, and then the biggest one, right, Birmingham is last. Not exactly. We don't just sort those ratios, not usually, anyway. Because critical ratio is a dynamic rule. It's meant to be used over time, in essence. Okay, you say, well, fine. Then what do? We need to fill in the rest of those blanks. How do I pick the second jet? You pick the second jet by projecting your first decision forward in time. You've decided to process the Belfast flight first. That means that, and here's something that's a little funny about just the global freightways problem. That means that the unloading crew will get busy on the Belfast flight. Just, picture it, and they'll unload it. They'll unload it. Now, this is the second page of the note frame, but you can also look up this information in the book. And the Belfast flight, this data here is saying that is 0.2 hours of unloading time. That means that 0.2 hours from now, the unloading crew will be finished with that flight, and they will be looking for something to do. 0.2 hours from now that you know that Belfast is what we're working on first, starting right now, 0.2 hours from now is when you're going to need to pick again. So we want to update the ratio values to reflect the fact that the next time we pick, it's 0.2 hours later. You go, oh, okay. How do I do that? It's just tables. Think tables. First off, we're going to create a second set of ratios. The second set of ratios represent the second time that we pick, when it's 0.2 hours later. We only need to, I am drawing 4 lines. We only need to, at this point, calculate 4 more ratios, because it's only an issue of maybe it's Birmingham, maybe it's Dublin, maybe it's Manchester, or maybe it's London. Critical ratio is always time remaining to work remaining. Here's the deal. We have scheduled Belfast, right? So for this second table, it is, and I'll just jot it over here, 0.2 hours later. You say, all right. So think about it. Time remaining for Birmingham. Remember our scratch work at the beginning? Birmingham originally was scheduled to leave 2.6 hours from now. That was originally. It's now 0.2 hours later. So the numerator in the critical ratio for Birmingham is now 2.6 hours, the original numerator, minus the 0.2 hours later. That divided by the same old processing time is the new ratio. Okay? You say, what? I aged the rule. I updated the ratio by aging the ratio ahead 0.2 hours, because that's the next time we would be looking at ratios and picking. Okay, now I just have to do it for the other 3 flights. Oh, all right. That means that, for instance, now here with Dublin, the actual finished numerator, right, was 2.4. I just want to note that because later that might be a number that I need. With Dublin, let's look. Dublin, scheduled to depart originally in 2 hours. 2 minus 0.2 is 1.8. It is now 1.8 hours until Dublin is required to depart. 1.8 hours. Dublin, how much processing time? 0.65. The denominator doesn't change. That I get 2.77. Say, okay, good. That's the ratio value for Dublin. Manchester, the original departure was in an hour and a half, but now minus 0.2. It is a little while later, which means it's 1.3 hours until Manchester has to depart. Manchester, same old processing time, 0.75. Updated rule, 1.73. So, okay. And then let's see, London. London wasn't going to leave for 3 hours, but now it's 0.2 hours later, so now it's 2.8 hours until London flight has to leave. It's still the same old 1.5 hour to process it, so an adjusted rule, I have aged it by 0.2 hours, because it's 0.2 hours later now when we're picking the values 1.82. So, again, we have a set of values. We're always interested in which one is the smallest one. This time there's clearly a smallest one. 0.2 hours later, the smallest ratio would then be Manchester. Oh, okay. What am I supposed to do with that? Schedule Manchester. Manchester will go next. We know that it's the second jet. Oh, okay. Then what? Then repeat. Then repeat. Now we know that the unloading crew will do Manchester next. They will unload the jet, the Manchester flight next. How long will that take them? I'm going to look it up in the data here. The original unloading time was a half hour for Manchester. 0.5. Oh, that means that I need to take these values and I need to age them a half hour further in time. Oh, the good news is, yes, third table. When it's a half hour later. The good news is now I only have to calculate 3 rules because we keep losing a jet each time. I'm again going to draw some lines just so that they stay straight. 3 flights, 1, 2, 3. This time we're still trying to find a place for Birmingham. And we're still trying to find a place for Dublin. And we're still trying to find a place for London. Let's see, in the case of Birmingham, the last time we were looking at that numerator, there was 2.4 hours until Birmingham was set to leave. That was the last time we were looking at that numerator. We made a decision and now it's a half hour later. So I take that 2.4 and I subtract out that half hour. Now we're down to, it's like a countdown. We're counting down. We are down to 1.9 hours until that particular jet leaves. Its processing time, that part never changes. We haven't touched that jet. So it's still a total of 0.25 hours worth of processing. Okay, I did that math in my notes. What does the ratio value amount to now? Okay, 7.6. Dublin, on the other hand, the last time we were looking at, we had 1.8 hours until that flight had to leave. Now it is a half hour later, so we are down to 1.3 hours until that flight has to leave. That's the time remaining. The Dublin flight is still a total of 0.65 hours worth of work that haven't been done. So I get 2 again. Another 2. Ratio value of 2. London, the last time we were looking at London, we were down to 2.8 hours until it had to leave. Now we're jumping ahead a half hour, so we're down to 2.3 hours before it has to leave. It is still, this part doesn't change, 1.5 hours worth of work. I get 1.53. Oh, these are the 3 updated values. I'm interested in the smallest one. The smallest one now belongs to London. Guess what? London gets picked next. London gets picked next. Now the only thing I have to do is pick between Birmingham and Dublin. I have to pick between Birmingham and Dublin, and I have to determine then, okay, well, what would the critical ratio be? How much later in time? If we're working on London, I'm looking at the original data. Well, London's an entire hour to unload, it says in the data. So I've got to age the ratios now another hour further to see who's smaller. Birmingham, again, or Dublin. In the case of Birmingham, the last time we were looking at that flight, we had 1.9 hours until it needed to depart. Now we know that we are working on the London flight in unloading, so it's going to be a full hour later, which means that we are down to 0.9 hours before it needs to depart. The denominator doesn't change. It's still a quarter of an hour. 0.9 divided by 0.25, I get 3.6. You say, oh, all right. Now the ratio has fallen to 3.6. Notice how they're getting smaller? In the case of Dublin, the last time we were looking at it, we were down to 1.8 hours before it had to depart. Now it's 1 hour later. So as we're trying to decide who goes fourth, we only have 0.8 hours until it has to leave. Dublin was what? Dublin was 0.65 hours worth of work. So I get 0.46. That's definitely smaller of the two. That just decided the sequence. Dublin. And then, you don't have to update the ratio again. Birmingham is the only one left over. It gets put on the end. Oh, okay. So if the freight depot manager really wants to use critical ratio to sequence these jets, that should be the sequence. That should be the sequence. Now notice with critical ratio, every time you schedule somebody, then you have to pretend like you've gone that much farther in time and you update the ratios. Oh, all right. Now, there was a question that was asked. If the Edinburgh Center uses critical ratio, all right, well, that's what we just did. What sequence would result? Okay, we got that part, but on the next page it says, how much more time will this schedule require than Johnson's rule? Oh, Johnson's rule was the subject of the scenario before this one. Johnson's rule was that rule that always finds you the schedule with the minimum make span, which is to say it takes you the least amount of time from start to end to do everything. From that, I wrote that down from scenario to B, the one before this. There was a sequence that was only 2.35 hours long when we mapped it out. That's the make span of, now wait a minute, that was the Johnson's rule sequence. That was the Johnson's rule sequence, and we're wondering, like, is this sequence any better or is it worse? First off, how much longer, if it is longer, how much longer is it than the Johnson's rule sequence? And then there's another question thrown in there, right? Okay, and if we follow this sequence, are any of those planes going to be late? Because that was a concern last time, the other scenario with Johnson's rule. Well, similar to last time, the best way to answer that is to draw a Gantt chart. We have the sequence. We know what the plan is, right? First we're going to do Belfast, then Manchester, and London's going to be in the middle, so on and so forth. That is the actual plan. But what we're going to do is illustrate the timing of the plan in order to kind of gauge these other questions. And so you can see that there's an empty frame here with the two processes, unloading and loading, all set to go for us to map out what our sequence would look like. A good scale is to let every column be 0.1 hours, and I'm not labeling every one, I'm labeling every other one, so 0.8. Like this is 1 hour from now, 1.2 hours from now, 1.4 hours from now, 1.6 hours from now, 1.8. Okay, this is 2 hours from now. Right there. 2.2, 2.4, 2.6. That's the timeline, because a Gantt chart is always showing you activity over time. All right, now illustrating our sequence. We go, okay, who's first? Belfast. Okay, what does Belfast need? Belfast needs 0.2 hours of unloading and 0.3 hours of loading. I'm just going to book that. Belfast is first. They'll start unloading it right away. So I'm sort of reserving the time. There they're unloading the Belfast flight. Once it's unloaded, it can be loaded again, because this was a two-stage process to turn the flight around. That was 0.3 hours would be required to do the loading. So I grab 3 columns and I book it. That's the Belfast flight. And then one thing I'm very interested in is, where does that wind up ending? On the scale, that's at 0.5. Good to know. Belfast flow time, 0.5 hours. Okay, so in our sequence, we will be done with the Belfast flight in a half of an hour, and it is free to leave again. Okay, now we can't address those questions until essentially we illustrate all 5. Okay, so who was next? We had decided to do the Manchester flight next. Okay, Manchester. Manchester is a half an hour of unloading and 0.25 hours of loading. A half an hour of unloading, that would be 5 columns. 1, 2, 3, 4, 5. I'm reserving the unloading time. It has to wait until Birmingham is finished. But this is Manchester. Once it is unloaded, it can then be loaded again. That's only 0.25 hours, so 2.5 columns. Just put an M there for Manchester. Okay, fine. Where did it end up? Well, it's in between 0.9 and 1 hour. Manchester flow time, when we'll be finished, 0.95 hours from now. Okay, then who's next? Well, that would be London. Okay, London is a big job. London is a full hour of unloading. Okay, after they're done with Manchester, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of this through here is the unloading crew working on the, and I can label that, London flight. When it is unloaded, you can commence loading it again. That's another half hour, but it can't start until right here. There's 1, 2, 3, 4, 5. A half hour's worth of time. London. And where did it end? That's at 2.2. Good to know. London flow time, 2.2 hours. Oh, now we're not done until all 5 of the flights are up there, but you can already see that this particular sequence has got some awkward features in that we didn't put anything in here. This is all idle time. It's just it's where the loading crew will finish up with Manchester, and if we do it in this order, they're going to sit around for a while waiting for the London flight to be unloaded, and that's also some idle time in there as well. Anyway, that's just a feature of this particular schedule. Okay, now wait, the 2 other ones. Who's in 4th place behind London? Dublin. Let me pick a contrasting ink color. Dublin, how much work? Dublin requires 0.3 hours of unloading. So I grab 3 columns. Well, this will be Dublin right in here. So when the unloading crew finishes, that jet will be empty. The loading crew is busy with London, while Dublin will just have to wait. It'll have to wait until they're finished with London, so we basically schedule it behind that. I'm grabbing 3.5 columns because that is unloading. And then I'm noting, where did it end? It ended right here between 2.5 and 2.6. So Dublin flow time is 2.5 hours. Now, one last one. Birmingham. Birmingham, let's see, Dublin, yes. Birmingham is, a small thing. Yes, 1.5 columns here for Birmingham. And then Birmingham, only 1 column. Because it's only 0.1 hours. Ooh. Birmingham flow time is 2.65 hours. Actually, I left off a 5 off of Dublin. It's 2.55 hours. Sorry about that. Birmingham's flow time, just a little while later, 2.65 hours. Oh, you say, well, okay, great. I have all these flow times. Now remember, the flow time in this particular setting is when you have finished with the jet and it is free then to leave again. You say, yeah, okay, but have I answered the questions? Well, one of the questions was, how much more time will this schedule require? You look at the flow time of the last job in a sequence. Birmingham was the last flight. When does it finish? That means the whole thing is finished in 2.65 hours. There's your answer, because from scenario 2B, that other sequence was only 2.35 hours. So you could say 2.65 minus 2.35 is, what's that, 0.3? How much more time will the schedule require? It is 0.3 hours longer. There's your answer right there to that question. Will any of the planes be late for departure now? Let's see. Will any of the planes be late for departure? I've got to grab the page before, because I've got to go back to find out that information on when were they scheduled to depart. Because if I compare their due dates, so to speak, the scheduled departure, with their flow times, I can answer the question whether they are or are not late. So let's check if anybody's late. Belfast, the flow time is 0.5 hours. It'll be done in a half an hour. I'm checking the schedule. Belfast was scheduled to depart in 1 hour. The due date is larger than the flow time. It's not late. I mean, it's going to be done in plenty of time. Manchester will be done in 0.95 hours. Check on the schedule. Manchester scheduled to depart in 1.5 hours. It's going to be done in plenty of time. London will be done in 2.5 hours, or excuse me, 2.2 hours. London scheduled for 3. Oh, that one's going to be done in plenty of time. Okay, then next is Dublin. Dublin will be done in 2.55 hours. Dublin, Dublin is scheduled to leave in 2 hours. The due date is smaller than the flow time. We found one that's late. Dublin's going to be late. Birmingham, let's check it. It will be done in 2.65 hours. Birmingham, when is it supposed to leave? In 2.6 hours. It's close, but Birmingham is also late. It's just a little bit late, but it will also be late. So, the answer to the 2 questions after all of this, the manager's thinking about using critical ratio. Well, after all of that work, the overall schedule is going to be 0.3 hours longer, which actually we kind of knew that was going to happen, because Johnson's rule from the previous scenario always finds you the shortest schedule. This one was never going to do better. But, well, maybe since it's fancier, it'll do better in keeping the planes from being late. No, not really, it turns out. If we follow this particular sequence, 2 of the aircraft are going to be late.